Welcome to day 16 where we're going to be classifying different triangles. So you have a page of assorted triangles and you have to go through and you have to label them. The two ways that we can classify triangles are shown on this worksheet from a previous day. It's good for us to review this worksheet before we start our work. We know that there are two ways you can classify triangles. You can classify them by their side length or by their angles. So, an equilateral triangle is a triangle that has three sides that are all the same length. An isosceles triangle is a triangle that has two sides the same length. And a scalene triangle has no sides that are the same length. You can see on these triangles that it's been marked with a little line to prove that those are the same length. So all three of these are the same length. But on this triangle, only these two are the same, and this one is a little bit shorter. That's what makes it isosceles. The other way that you can classify triangles is by looking at their angles. You can see that this triangle has a right angle, or that perfect L shape, that's 90 degrees. A right triangle has one right angle. The other two angles are going to be acute angles. An acute triangle, though, has three acute angles. So every single angle in this triangle is acute. That's what makes it an acute angle. And an obtuse triangle has one obtuse angle. The other two angles are going to be acute. But you can see right here that this angle is obtuse. So that makes it an obtuse angle. When we're looking at our page again in a moment, we're going to be looking at both the side lengths and the angles to classify our triangles. So keep this sheet in mind and click back to it as often as you need to make sure that you're classifying your triangles the right way. Now, I'm going to start looking at each of these triangles, and I'm going to look at their side lengths. In their side lengths, I'm going to show you with blue, and I'm going to look at their angles. The angles I'm going to show you in green. I'm going to go through each one of these triangles that's listed on the page, and I'm going to sort on it and write on them, okay? You may have done this on your Google Slides where you took each triangle and you were able to move it around. That's okay too. I just want you to see what each triangle is categorized based on its side lengths and its angles. I'm going to start with E and then move my way through the page. Okay. The first thing that I notice when I look at triangle E is that all three sides are the same length. So I'm going to do those little marks that prove that they're the same length. And that makes this triangle an equilateral triangle. So I'm going to write EQUIL, just for short for equilateral. I know that triangle E is equilateral because all the sides have the same length. Now I'm going to look at the angles. This angle is acute, this angle is acute, and this angle is acute. So this makes this triangle an acute triangle because all three angles are acute. Now I'm looking at triangle H. I notice triangle H looks just like triangle E, but it's a little bit bigger. I'm paying attention to the side lengths, and I notice that all of these side lengths seem the same. So I'm going to mark the side lengths, and I'm going to call this an equilateral triangle because all three sides are the same. Now I need to look at the angles. Even though this triangle is bigger, the angle is still acute. This angle is acute, and this angle is acute. That makes this an equilateral and an acute triangle. I noticed something different about this triangle. Right away, I can tell that it has a right angle, or that perfect L shape there that makes a 90-degree angle. So I know that this is a right triangle. Now I need to look at the sides. I think that this side and this side are the same length, so I'm going to mark them. But I notice that this one is a lot longer than the other two. So that makes this an isosceles triangle. I'm going to write ISOS just for short. Looking at triangle A, I can already see the 90-degree angle. That's the first thing that I can tell. So I know that this is a right angle as well. Now I need to look at the lengths of the sides. This is the longest side. This side is a little bit shorter than that, but this one seems shorter than that one. So I know that this is a scalene triangle. I'm going to write SCAL for short, for scalene. That means that none of the sides are the same length. Now I'm going to look at triangle F. Triangle F, I can tell, also has a right angle. So it's going to be a right triangle. Right triangles only need one right angle. The other two angles are acute. Now, if I look at the side lengths of this triangle, I can see here that this one is a really long one. This one is really short, and this one is in the middle, which means that none of the sides are the same length. So that also makes this a scalene triangle. I'm looking at the next triangle, triangle I. I notice on this one too, it has a perfect right angle. So I know that this is going to be a right triangle. Now I need to look at the side lengths. I have to decide, this is the longest side length. This one is a little bit longer, but I have to think, is it the same as this? In my mind, I try to pull this angle down, and I can tell that it's not exactly the same. So this is another scalene right triangle. SCAL. Looking at triangle B, I notice right away that this side and this side are the same. But I need to look at this third one, and it looks a little bit shorter. So that makes this an isosceles triangle because it only has two sides that are the same. Now I need to look at the angles. This one is acute, this one is acute, and this one is acute. None of them are bigger than 90 degrees. So that makes this an acute triangle. Looking at triangle C, it is a very tall and skinny triangle, but I notice that this side and this side are the same length. This side is obviously smaller than these two long ones, so that makes this an isosceles triangle. Now I need to look at the angles, and I have to think, are they acute, right, or obtuse? This one is acute, this one is acute, and this one is acute. So that makes this an acute triangle. Now I'm looking at triangle L. Triangle L has something interesting about its angle. I can tell that this angle right here is bigger than an L shape. It doesn't make a perfect L shape like a right angle. It's a little bit bigger. That makes this an obtuse triangle. An obtuse triangle has at least one obtuse angle. The other angles can be acute. Now I have to look at the side lengths of this triangle, and it looks like to me that this is the longest one, and this one is a little bit shorter. This one is definitely shorter than the other two. So this does not have any sides that are the same. That makes it a scalene triangle. Let's look at triangle N. If I look at the sides of triangle N, I notice that this one and this one are the same length, but that this one right here is shorter than both of the other ones. That makes this an isosceles triangle because two sides are the same. Now I need to look at the angles. This angle is acute, this angle is acute, and this angle is acute. So this is an acute triangle. I'm going to go ahead and look at triangle M. I notice on triangle M that the sides look like they might be the same right here and right here. So I'm going to mark that as the same. But this one is a lot longer. So that makes this an isosceles triangle. Now I need to look at the angles. This angle is acute, this angle is acute, and this angle is actually a little bit bigger than the L shape, so it makes it an obtuse angle. You can tell here that if it were an L shape, it would go perfectly straight like an L, but this one goes a little bit further and makes it an obtuse triangle. So triangle M is isosceles and obtuse. Let's look at triangle D, this really funny looking one at the bottom. I can tell right away that this is a long side and this is a very short one. But I need to look to see if this side matches the other lengths. And I notice it does not. So this is a scalene triangle. It does not have any sides that are the same length. Now I need to look at the angles. This angle is acute. This angle is acute. But this angle is a little bit bigger than an L or a right angle. So that makes it an obtuse angle. So this is a scalene and obtuse triangle. Now I'm looking at triangle K. If I look at the sides of triangle A, or it's triangle K, I notice that they are all really close, but they're not the same. That makes this a scalene triangle. None of the sides are the same length. Now, let's look at the angles. This angle is acute, this angle is acute, and this angle is acute. So this is a scalene acute angle. Let's look at our last triangle here, triangle G. One thing I notice about triangle G right away is this obtuse angle. It's a little bit bigger than an L shape or a 90-degree angle. The other two angles are acute, but this obtuse angle makes it an obtuse triangle. Now I need to look at the side lengths. I look at the side lengths and I notice that this is my really long one. There are no other sides that are the same as that. But this side and this side seem to be the same, which makes this an isosceles triangle because two sides are the same length. I hope that you've noticed that as we're going through and we're sorting these, we can look at the side length and the angles to classify our triangles. Good job on day 16.